So the first step of this lab is figuring out how to interpret the signals of our encoder. Now we've got 5 volts connected to it, so 5 volts here, ground there, and we also got our pins A and B, which we will be monitoring on the oscilloscope. So let's see what happens if I'm turning it clockwise. So that's what happens when I'm turning it. And if I go counterclockwise, that's what happens. Now I'm going to show you how to interpret those signals properly. Alright, so let's look at how to interpret those signals A and B. So when you're going to turn it in a certain way, as you saw from the oscilloscope, they're going to alternate like 0, 0, 1, 0, 1, 1, 0, 1, or 0, 0. And if it's the other way, it's going to be 0, 0, 0, 1, 1, 1, 1, 0, and 0, 0. And then it repeats if you go in the same direction. So let's say this direction here is clockwise. Again, I'm just saying this arbitrarily. So, and this is counterclockwise. So what we're going to be doing is in the Arduino code, we are going to set up an interrupt function. Now this function, when the conditions are met, it will do a specific task that we tell it to do. So in this example, we're going to say, oh, well, when signal A is going up, so it's going in an upward transition, okay, it's going to look at, it's going to read what's on signal B, so it's either 0 or 1. And during this brief period of time, either signal B already went high, like in this case, or it's still low. So depending on that reading, we know whether we're going clockwise or counterclockwise. So let's say you turn it clockwise, right? And signal B already went high. Well, then it reads that signal B is already high here while it's going up. And it will know that it's going clockwise. And with this information, we could increment or decrement our position. So that's how we're going to be able to get feedback on our position from the motor. Alright, so in the first part of the lab, we're going to define encoder A to be at pin 2. So the signal coming out of your encoder will be connected to the pin labeled 2 on your Arduino. Same thing with encoder B to pin 3. Here, this is standard serial begin at 9600. Pin mode encoder A input, so you're basically defining encoder A and encoder B to be both inputs. And in your loop, you will say integer A is equal to digital read encoder A. So this will read a value of either 0 or 1 because it's digital. So it's going to tell you what encoder A is seeing, like what pin 2 is seeing on your Arduino, and tell it this is what A is. Same thing for B. And we are going to print out A times 5, so it's going to be, inside here is going to be equal to 0 or 5, because it's 5 volts that we're using, so figured to scale it properly, you need to multiply it by 5. And then you print a new a new line. So let's upload the sketch. Done uploading, and let's see, serial plotter. All right. Okay. So when I turn it, you could see this is turning clockwise, and the blue signal always goes before whenever like goes before the red signal, right? As you can see. Well, okay. So if I go counterclockwise, as you can see, red goes high before blue does. And if I go the other way, you'll see blue goes high before red does. And so, depending on which one goes high first, we'll be able to evaluate if we're going clockwise or counterclockwise. All right, so in part 2 of the lab, we're going to define this as we've done before. Now we're also going to say position, integer position, is equal to 0. So that's to start off sequence. Now this we've seen. Now attach interrupt. Now what this does is it attaches encoder A to be like an interrupt. So whenever it's going to be rising, okay, so it's going to go up like a upward transition, it's going to basically perform this function. So whenever encoder A, when this condition is met, because this could also be falling, but here we have it at rising. So whenever it's rising, encoder A, it will detect this and perform read encoder function. Now, what does it do? Well, it defines B as digital read B, so it's either 1 or 0. So it checks whether B has already gone high or not, because you've seen that whenever we turn the encoder one way or the other signal either leads or lags. So if it's high, then it knows that we're going clockwise. So it will simply increment the position. So this is a shorthand form to write increment the position. So just go position is equal to position plus 1. Well, instead you could just write plus plus. If B is still 0, in this case, it's going to decrement. So it's going to go position minus minus. So this will track the position of your encoder. So let's upload this. Okay, and stereo plotter. So you see it starts out at 0, and when I turn it, and then I turn it back here. So it accumulates the position, right? So the amount of like steps it took. Yeah. So that's pretty much it. All right. So in part 3 of the lab, we're going to define encoder A and B as we've done before, but we're also going to define PWM pin to be at pin 5. Now pin 5 is a special pin because it allows us to get a PWM signal. So this PWM pin will connect directly to your enable A of your H-bridge driver. In2 is also on your H-bridge driver, and so is your in1. So they both connect to your 6 and your 7. So we still say position equal to 0 at the very beginning. And this we've seen before. Now, set motor. This function is new. Let's see what it does. So over here, I tell it its direction to be 1. So here I pass a parameter called direction, and I make it equal to 1. So what this will do is it will simply make in1 and in2 go high or low. So it sets up the H-bridge so that it could go forward. So direction, if it's 1, it makes it go forward. If it's -1, it's going to do the opposite of whatever it did when it does 1. And it's going to basically make it go in reverse. And if it's 0, well, it's going to simply make it stop. So when both ins are low, it makes it stop. Second parameter that we put into it is the PWM val. Okay? So we're going to write analog write PWM pin comma, PWM val. So we are going to write to this pin, right, PWM pin, which refers to our PWM pin here, which is pin 5. Okay, so like it knows how to follow this. So you got to say which pin you're talking to and essentially PWM val, which you're determining here. One thing to note is that this is an integer 8. So this means that it's going to be a value between 0 and 255. But we humans work with a duty cycle, and usually it's between 0 and 100%. So you got to scale them properly. So if you want 0%, you're going to write 0. If you want 100%, you're going to write 255 because that's what it corresponds to. So yeah, and these it simply passes it back and back here. So that's what it does. It basically enables you to determine the duty cycle and also the direction. So yeah, so in this loop we say it set motor, go forward at full speed for 2 seconds, and then we're going to print the position. Then we're going to do the opposite and reverse 2 seconds, print the position again, and then we're going to make it stop here for 2 seconds, and that'll be that. So it's going to repeat this cycle infinitely. And yeah, so let's upload this. Serial plotter. So I'm sure you could hear in the background where it's going forward and reverse. So it's making a wave. And so yeah, that's basically it. Okay, so for this last part, part 4, we're going to do the same things here as we've done before, but we're going to define a few more variables. So there's previous t, previous error, and e integral. Okay, so you're going to first zero them out at the very beginning. So that's what we're doing. Here we're printing the target position. Okay, and over here we're setting the target value. Okay, so this is just an example. We could have it lower, or we could have it higher, or we could even have it follow a sine wave, as we have here. These values, these are part of your PID equations. So you've got Kp, Kd, and Ki. You got to change them to whatever makes the system perform better. So that's really up to you to define these parameters. And this one as well, because you may want different targets. All right, so let's go into this. So current time is equal to micro this. Okay, so this basically counts the amount of time it took in microseconds to go from here to here. So that's what current time is. Okay. So it's going to give us a few decimal points because that's what a long allows us to do. So it gives us current time in microseconds. Okay, so that's 1 times 10 to the minus 6 seconds. Now, delta t is our change in time. Float, we just want a few decimals. So current time minus previous time. Okay, so that's delta t. So current minus previous, that's delta. And this here is to convert microseconds to seconds. And at the very end, we're going to make previous t equal to current time. Okay, so when it cycles, it's taking your current time and making it your previous time and putting it back into here. And if you recall properly, previous time, at the very first line here, we make it equal to 0 for the very first condition, okay? But then it will change. Now, int error, it's your position, so where it's at and where it wants to be. So this is what we call the error. These follow essentially the formulas for PID, and this is what we're really interested in. So U will become our power, okay? We're going to take power, find its absolute, well, we're going to find U, take the absolute value of U, because it could be negative or positive, and that is going to be our PWM val signal later on in our set motor. So whatever it is, it's going to be positive, and it's going to be between 0 and 255. So this is what that does. Now, if we have a positive U, okay, we are going to make direction go forward. Now, if we have a negative U, we're going to make it go reverse, okay? So that's basically saying, oh, we're above our target value, well then let's make it go lower so it changes the direction of the motors properly. And then with this being done, we're going to set our motor to perform what we want it to do. Now, direction, it's going to take either -1 or 1, or is yeah. So we're going to take direction here, PWM val, yeah. So our power will be equal to our PWM val, and this stays the same as we've seen before, same as this, and same as this. So really all we're adding is the PID elements to it. So if this here is 0, okay, so if your U is 0, your power will be 0, okay? So that's why we don't need to say if direction is equal to, well, to make if U is equal to 0, then make direction equal to 0. We don't need that, because if U is 0, then the power is going to be 0, and it will just not move. So yeah, that's pretty much it. Now let's upload. Okay, is it done? Yes. Okay. So let's run this and let's see what's happening. So as you can see, it tried to reach that target. It got pretty close, but it's not perfect. So essentially what you want to do is mess around with these values to basically match what you need. So what we've found that works very well is I think this is it. Let's upload it and let's see what happens. So yeah, as you see, it got very, very close. It's about, it's 115 steps too high. So yeah, so you want to adjust your things properly. Other than that, that's it for the lab. All right, so let's do an extra example using a sine wave. So as you can see, I commented out target position here and uncommented this part. So let's see what happens when we upload it and track it. All right, done uploading. Let's go to serial plotter and turn out output on. So as you can see, it's making a big sine wave as our target. So our target is always moving. So as you can see, it follows the sine wave pretty nicely, if I do say so myself. So you could try other functions, try other parameters, really find out what's the best set of combinations to make your system work better. All right, that's it. Okay, so like I said, you could find your own parameters, but I've changed them a little bit. So here I put 60, 0.001, and then 1. But feel free to really change and experiment with these values. And also, I divided this here by 2 because the way that it was increasing would be too drastic for the motor to even keep up. So this is just a way to slow it down a little. And to really see it slowing down and then picking back up the speed. Another thing that you might need to change is these things here. If you see that it's always going in the opposite direction that you want it to, simply change pin 6 and 7 like I mentioned previously. So that's it. Okay, so let's take a closer look at the wiring. Now, first and foremost, we are using an H-bridge here. So we're using the L298N. So you can find these at your electronics store or even on Amazon or possibly on Alibaba or whatever. So this is what we're using. We're using a power supply that has 2 channels and a constant 5 volts here. And we also have an Arduino Uno right here, and we also have our encoder here. Okay, now it's important to note that the encoder knob here that you see is actually physically linked to the encoder to the motor shaft here. Okay, so you got to keep that in mind. So you got to either hot glue it or make some kind of link to connect your knob from your encoder to the shaft of your motor. All right. So without further ado, let's get into it. Now, over here in your H-bridge, you have your out 1 and your out 2. So these will change polarity, so it doesn't matter which side is connected to which on your motor. You just need to connect both of them. You gotta also make sure that this jumper here is on, because that enables the 5 volt regulator. So if you don't put it, you're gonna have trouble. So since you're using 12 volts. So you're going to hook that up to 12 volts here. This goes to ground, connected to here. Enable A, like we've said, goes to the PWM pin right here. So this symbol represents the PWM signal. So it goes to enable A. You're going to, if there was a jumper here before, remove it and just plug in that first wire. Then the next pin next to that is in 1, which will connect to 6 on your Arduino. 7 will connect to your in 2. And the rest of the pins, we don't use them, so ignore them. Like this would be out 3 and out 4, but again, we don't use it. Next is our Arduino. We have a special connection connecting the power of our Arduino. Instead of having a barrel connector, we just have a screw terminal. So we have a 9 volt power supply going in, and you have our ground connected to it here. So it's important to always use the same ground through all your applications. That's why I made the symbol, but it would all be connected. So this to that. So you got to keep that in mind. All right, and now for the encoder, this is how you do it. You put 5 volts here, ground here, and your A will go to pin 2, and your B will go to pin 3. Or you could keep them straight and change that in your code. So it's really up to you. So that's pretty much it for the wiring. All right, so let's take a look at how we physically connect them. So over here, we've got our 9-volt power supply. So that connects to your 9-volt power supply here, right there. You have a wire here that goes ground, which goes to the ground of your H bridge. And you also have another ground going to the ground of your encoder. So that's how you're connecting the grounds together. Next, we have the motor outs here, connecting to both ends of your motor. And you also have your in 1, in 2, and enable A, all connected in order there to pins 5, 6, and 7. And lastly, this here, you'll connect it to your computer. That's how you program it. And it also sends back data, as we've shown with the serial plotter in the when we're showing the code. So without further ado, let's show it working. Before that, I just want to point out this is how we've linked it together, the shaft of the motor and the encoder. So you see that we've 3D printed a piece that would fit on the knob and also on the shaft, because they have like a nice curvature to them. So like the encoder had like a D shape, and this had like a strange shape, but we managed to replicate it on a 3D printer and connect both ends together. So let's turn the output on. So there you go. So it's going forward and reverse and following that sine wave that we demonstrated earlier. Okay, we could turn the output off.